Hello, welcome to the third lesson of Chapter 6, and today we're going to be looking at the law of sines. You've learned it mostly in your previous year, but we're going to go through it again, and we're going to get into a little bit more complicated situations. Now first we have to remember something about triangles. What conditions guarantee you that the two triangles are congruent? If we know all their sides are congruent, that will work. Side angle side will work. Angle side angle will work. And angle angle side will work. So that leaves SSA or AAA that do not prove congruence. Now the law of cosine is based on which rules? Well, we'll use side angle side to find the opposite side, and we can use side 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 to find an angle. Alright, now let's find a proof, or do a proof, for the law of sines. Now, if we have this triangle, we can find the area of this triangle using this angle, and its area equals 1/2 AB sine C. We learned that in our previous lesson. But we could also say area equals BC, 1/2 BC times the sine of A, or area equals 1/2 AC times the sine of B. All of these are equivalent because the area of this triangle is going to be the same regardless of what angle we're choosing. So what I can do to each side of this equation is divide it by 1/2 ABC. And let's look what happens. The 1/2 will cancel out, the AB will cancel out, the 1/2s and the BCs, and the 1/2 and the AC. And what's left over here is the sine of C over C, is the sine of A over A, which equals the sine of B over B. Now, sometimes you'll see it written like this, and other times you'll see it flipped over where it looks like this. Either of them will work just fine. They're equivalent. Now we use the law of sines when we have two angles and one side, so AAS or ASA. So in this situation, if I want to find it GH, which is this side, let's call it X, what I would do is I'd say the sine of 50 over its opposite side, which is 5, is going to be equal to the sine of 72 over its opposite side, which is X. So now you take your calculator, cross multiply and divide to get 6.21 if we're rounding to 2 decimals. Alright. Now if we do this, finding BC, that's this side over here, well, we know one side, 50. We'd need to find this angle in order to use the law of sines. We can add these two together, and that would be 120. So this would have to be 60 in order for all the angles to add up to 180. So the sine of 60 over 50 is going to equal to the sine of 35. We use this one because it's opposite of x over x. Now we can cross multiply and divide to find the value of x. So 50 times the sine of 35, divide that by the sine of 60, and you get 33.12. And do we have units on this? No units. So 33.12 units. Let's find AC. AC is on the bottom. Here again we have 115 and 25. So this angle has to be 40. So I could say the sine of 40 over its opposite side of 43. AC is on the bottom, so let's call that x. It's going to be the sine of 115 over x. So 43 times the sine of 115 divided by the sine of 40. That gives us 60.63. X equals 60.63. All right, hopefully that makes sense to you by now. Now we're going to try to find this angle here, h. So we'll do the same system. We'll say the sine of h over 18 is equal to the sine of 75 over 25. Now over here we'll cross multiply and divide. So we have 18 times the sine of 75 divided by 25. So that would equal 0.695466, or let's say 67, is equal to the sine of h. So if that's what the sine of h equals, now the proper way to get rid of this is to do the arc sine. So h is equal to the arc sine of 0.695467, which if we just do the inverse sine of that answer, I get 44. So h can be 44, or h could be 180 minus 44, which is 136. Now, if I put 136 here, 136 plus 75 is way too much. So 136 is not possible in this situation. So 44 is our only possible answer. So 44 degrees has to be our value for h. In triangle ABC, now I don't know what my triangle is going to look like. So what I'm going to do is I'm just going to make a generic triangle, label it ABC, and now I'm going to label this as 63. Little b is always across from big B. 9, little a is 12, and I want to find this angle here. So I'll say the sine of angle B over 9 is equal to the sine of 63 over 12. Cross multiply and divide. So now I take the arc sine of both sides. Well, if I take the inverse sine, I'll get 41.9. This is the roundest degree, so let's say call it 42. And then 180 minus 42 is 138. And 138 is too much because 138 plus 63 is over 180. So we only have one answer for B, which is 42 degrees. Let's try this one. Try this one on your own and see how far you get. All right, if I have P, Q, R, P is 45, Q is 87, little r is 11. Let's find Q, which is over here. So 45 plus 87, subtract that from 180, and this is going to be 48 degrees. So I'd say the sine of 48 over its opposite side is going to equal the sine of 87 over its opposite side. So I cross multiply and divide. So Q is equal to 14.78 centimeters. This one actually has units. Wonderful. All right, so now we're going to get into the ambiguous case of law of sines. And up here you were probably saying this is ridiculous. Why is he doing arc sine? And it's for this case. Now the law of sines, in the past we've used when we have ASA and SAA, and cosine, law of cosines when we have SAS and SSS. Now we're going to slide SSA into this situation. Now SSA does not prove the two triangles are congruent. However, we can use that to help us solve these triangles. Now if we look at this ambiguous case, if I have 4, 10, and 20, if I want to find angle C, let's say, let's say the sine of 20 over 4 is going to be equal to the sine of, let's call this theta, over 10. If I cross multiply and divide, I have 10 times the sine of 20 divided by 4. So I have the sine of theta is equal to 0.8551. So when I take my arc sine, my theta will be 58.77 degrees, or 180 minus that, which is 121.23. Now from this drawing, if this drawing is accurate, hopefully you'll see that 58 does not make sense with this drawing. 121.23 makes sense with this drawing. So it kind of depends on whether you have a drawing that is accurate. If it says that the drawing is not to scale, you'd have to find out all of these other parts with both situations. But if this drawing is accurate, we know this is an obtuse triangle, so 121.23 would be that angle. And if we just round it to the nearest degree, 121 add that to 20, subtract from 180, and we get 39. So then we could find x by saying the sine of 39 over x is equal to the sine of 20 over 4. So 4 sine of 39 divided by sine of 20. So then the side would be 7.36. Now, in that situation, there's two different triangles that could be created. We could have created this one where we got the 121, or the other one was like about 59, and that would have happened if this was swung out here. So we'd have 59. So there's two triangles that can be created with these values, 4, 10, and 20. And I could, draw them both on the same triangle. That 4 could be there or there, and these two are still the same. So that doesn't, there's two different answers we can have for x. All right, so this is just going through finding the different lengths. Now in this case, there is only one triangle possible. Whenever this opposite side is larger than the side next to it, there's only one triangle that is possible. Whenever the side opposite is shorter than this other side, what we'd have to do is, it could be 0, 1, or 2 triangles. And what we'd have to do is the law of sines to figure that out. So if I do the sine of 38 over 17 is equal to sine of theta over 27. If I multiply that out, 27 times the sine of 38, divide that by 17. Now when I take so I had the sine of theta is equal to 0.977. And when I took the arc inverse sine, I got 77.9. Now if I take 180 minus that answer, I get 102.1. Now, if are both of these possible in this situation? We're looking at this angle down here, and it looks like it's probably acute, but if this is not drawn to scale, maybe it could be either one of those. And it's not too much. If this number was too high, where if I added it to 38, it wouldn't make a triangle, then we can scratch it out. But both of these are reasonable answers. So in this case, there are two triangles that can be done in this situation. How many triangles are possible here? Well, in this case, the opposite side is larger than the adjacent, so there's only one. And in this case, we have to do it out. Sine of 14 over 5 is equal to the sine of theta over 12. If I take the inverse sine, theta will be 35.5 over 180 minus that, 144.5. Now both of these added to 14 is less than 180, so there are two different triangles that can be created with these three sides. So try this one. Find all the possible sizes for angle B if these dimensions are true. So let's draw our generic triangle and fill things in. We have A, B, and C. AC is 5, BC is 7, angle A is 30. So I can say we're looking for angle B. So the sine of 30 over 7 is equal to the sine of B over 5. If I cross multiply and divide, my sine of B is going to be 5 times the sine of 30 divided by 7, which is 0.3571. And if I take my arc sine, I'm going to have B is equal to 20.925, or 180 minus that, which is 159.075. Now if I add 30 to this answer, can I get another value for C? And that answer is no. So 20.925 degrees is the only value that will work for B in this situation. And we could have also seen, because the opposite is larger than the adjacent, that there's only going to be one angle. All right, let's try this one. So we have our triangle. We have angle A, B, and C. Angle or AC is 5, BC is 7, and this is 30. So it's pretty much the same situation, just the 7 and the 5 are flipped around. Oh, no. Same situation altogether. Sorry, I wasn't paying attention. 20.925. And what we just need to find now is the side AB. So 30 plus 20.925, subtract that from 180, and this is 129.075. So the sine of 129.075 over x is equal to the sine of 30 over 7. So 7 sine of 129.075 divided by the sine of 30 is going to equal 10.869 centimeters. All right. Now give the possible lengths for PQ given these situations. So I'm going to start by drawing my triangle. Now some people look at these problems and they just get confused because they don't know where to start. Whenever you're in that situation, just start drawing your triangle. Start drawing something that sometimes once you see it, it will all make sense. So now that I have everything filled in, I have an SSA. My opposite is less than my adjacent, so there's two possibilities. It still could be 0, 1, or 2, but I'll say the sine of 60 over 4 is going to be equal to the sine of Q over 7. So when I cross multiply and divide, I'll have the sine of Q, not theta, is equal to 7 times the sine of 60 divided by 4. And in this case, 7 times the sine of 60 is 6.06 divided by 4, and I got 1.5155. You can't take the inverse sine of this, so this is not a triangle. All right. So there's 0 triangles possible. Now let's do this one. Oops, that's definitely not a good start on my triangle. Take 2. So I have my PQR again. Pretty bad Q. PR is 7, QR is 10, and angle P is 60. So I do the sine of 60 over its opposite side of 10. It's the side of Q over 7. Cross multiply and divide. Sine of Q is equal to 0.606. Inverse sine of that answer is 37.317. And 180 minus that answer is 142. But 142 plus 60 is too much. So 37.317 is the only possible answer for Q. So now I add these together. Subtract from 180. And I get 82.683. So if I want to find PQ, I take the sine of 82.683 over PQ and set that equal to the sine of 60 over 10. So 10 times the sine of 82.683 divided by the sine of 60. PQ is equal to 11.453, probably centimeters. Yep. All right. Hopefully that helped out. And there is a worksheet for tonight. Good luck.